We're going to be talking about basically values that are, if they're in their decimal form, in decimal form it's a value that repeats or a value that stops, it terminates. So let's go ahead and write that as a little side note. A rational number in decimal form, it either repeats or terminates. So repeats means that it's going to have the exact same number or set of numbers over and over and over again. So like 0.6 repeated, 0.6666666, and it keeps going, okay? I said more than 3, thank you. It also could be a set of more than one number that repeats. So maybe it's 0.02020202, and it just keeps going with that pattern. Sometimes the repeated value isn't always going to be what you start with. So for example, 0.083, and then the 3 repeats. So it's 0.083333333. Okay? So those are repeated numbers. They are considered to be rational. Terminating numbers are numbers that actually have a stopping point. So like 0.25, that was 1/4. 1/5 is 0.2. 1/8 is 0.125. So they have finite stopping points. That makes it a rational number. If it does not have a pattern to it, it keeps going on forever and ever and ever, and there is no repetition, then those are called irrational numbers. And we're going to get into that next semester, talking about irrationals. So what we're focusing on is how to convert repeating decimals into fractions, because you already know how to convert regular fractions into decimals and regular decimals into fractions. That's easy. But when you're going from a repeated decimal into a fraction, that's a little bit harder. Okay? So let's say that we have 0.7 repeated. Okay, that means that that 7 is going to continue going on and on and on and on and on. How we convert it is we use a little bit of algebra. So I'm going to use the algebra to basically show you the idea behind it. So I'm going to state that x is equivalent to 0.7 repeated. So 0.777, and it just keeps going on and on and on. Now, what I'm wanting to do is I want to get one whole sequence of repetition past the decimal point. So what amount of numbers repeats? Just the 7, right? So it's just one number. It's one value that's actually repeating. So I only need to move 1 7 past that decimal point. Well, in order to move numbers in front of the decimals or behind the decimals, you use base 10s. So what we're going to do is we're going to multiply by 10 to move the repeat into the whole number. That's basically the idea of it. We're trying to get that repeated sequence into our whole number. So if I multiply by 10, that's going to move it once. Now if I multiply this side by 10, so if I'm multiplying this 0.777 by 10, then I have to do the same thing to the other side. I have to take that x and multiply it by 10 as well. Whatever you do to one side, you have to do to the other. So 10 times x is going to give us 10x. And 10 times 0.7 repeated is going to give you 7.777, and it just keeps going on. So now we're going to use some manipulation. I'm going to go ahead and I'm going to subtract my repetition expression from here. So subtract by the original equation. and this is the original. So I'm going to go ahead and subtract x equals 0.777 dot dot dot. Okay, so if I did 10x minus x, what do I get? 9x. And now if I do 7.7 repeated minus 0.7 repeated, what am I left with? Just 7, right? All of this information right here, all this, they're going to cancel each other out, aren't they? Because they're all the same. So you just have 7 minus 0, which is equal to 7. So now you have the equation 9x is equal to 7. How do we solve that? Hi. Oh, okay. So how do we solve that? Josh? 7 divided by 9. Now, I've told you guys before that you can go ahead and leave these in fraction form because it's not going to come out. I already know 7 divided by 9 is going to give me 0.7 repeated. So if I just simplify by 9, I'm going to leave it in fraction form because that's the goal. I wanted to convert into a fraction. So here's my fraction. 7 over 9. That's it. Okay, so once again, all you're doing is you're taking the repeated decimal, setting it equal to x, multiplying by a base of 10 in order to be able to move that repetition to one side in front of the decimal so it becomes a whole number, and then subtract the two equations from each other so that you can solve and get it in fraction form. Okay, so let me show you another example real quick. Let's say we've got 0.48 repeated. The whole thing repeats. So one more time, we're going to set x is equal to 0.484848. I'm just going to keep writing those out. And now I want to get the repetition in front. So what number or numbers needs to be moved to the front? 48, right? 48. So how am I going to move two numbers to the front? Times it by 100. Okay? So now we're going to go ahead and we're going to multiply by 100. So we're going to do 100 times the x. And we're going to do 100 times that 0.484848. Okay? That'll give us 100x is equal to 48.484848. And it keeps going. Now what do I do? Colin? Yep. So now I'm going to subtract my original from it. So I'm going to subtract x equals 0. So I'll put two zeros, it's fine. 0.48 repeated, right? Okay, and by subtracting, that's going to leave me with what here? 99x is equal to what? 48, right? Because all these 0.48s are going to cancel out, and you're just left with 48. Okay, now we'll go ahead and divide both sides by 99. And you'll get x is equal to 48 over 99. However, this can be simplified. They're both divisible by what? Miles? 16 over 33, because they're both divisible by 3. Okay, so we would have 16 over 33 as the final answer. Any questions about that? All right, I'm going to let you guys try one on your own. Actually, I'm going to let you try 2 of them on your own. Oh. It will be posted online tonight too, okay? Quick, 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 hurry. 5, 4, 3, 2, 1. Sorry. Okay. You can always get it from somebody else, or you can get it online later. All right, so here's the couple that I want you to try on your own. So if we've got 0.18 repeated, and 0.3174 repeated. right, who can tell me what they got for number 3? Jordan? 2 11s, very good. So if we go ahead and set this up as x is equal to 0.18 repeated, I know that I'm going to have to multiply it by a value of 100 in order to be able to get my new expression and get this repetition over to the other side. So this would become 100x is now equal to 18.181818 repeated. I would then subtract my original expression, so I'm going to subtract x equals 0.18 repeated. When I do that subtraction, it's going to leave me with 99x is equal to 18. I then would divide both sides by 99. And I would get that x is equal to 18 over 99. However, this can be simplified. They're both divisible by 9. And I would get that x is equal to 2 over 11. Okay, what about for problem number 4? Joshua. 374 has to be simplified. Colin?
You're kidding me.
Stop. 3,333. Yep. Okay, so you would have to be able to simplify it. Now, am I going to give you something as astronomically loud as that? No. Okay, I'm not going to give you something like that. You'll probably have it where it'd be a 2-digit or maybe even a 3-digit repetition that is easy to identify that it needs to be simplified down. But I'm also going to show you a quick trick after, because I wanted to show you guys the science, or the not really the science, the math behind why you can create these fractions, and then I'm going to show you the shortcut in just a second. So there's always shortcuts.
Yeah.
But see, here's the thing. If I tell you guys the shortcut first, you never understand the reasoning behind it. And so then when it gets down to doing something like milestones or CEPT exams or anything that's requiring explanation, you don't have something like the actual background knowledge to help you explain or justify. You need that background knowledge, that understanding, to be able to give justification and reasoning. That's all a part of what you're going to be doing now. And when you guys get into your algebra class next year, it's not multiple choice exams anymore. So you won't be having just a plain multiple choice exam. It will be short response exams as well, which require background knowledge. So you need to make sure you understand the why before you can do the shortcut. Okay? And then sometimes knowing the background stuff helps make the shortcut easier. Okay? All right, for here we have how many numbers repeating?
4.
4. So we're going to multiply it by 10,000. We're going to multiply it by 10,000. So that's going to give us 10,000x is equal to 3,174.3,174 repeated. Okay? Then we're going to subtract x equaling 0.3,174 repeated, which is going to give us 9,999x equals 3,174. You would then divide both sides by that 9999. He's being silly. I wanted to, but I'm being recorded. You know, that silly stuff. All right. Okay, you sounded German there. So seriously. All right, we're trying to break my son out of the habit of, he's constantly doing this.
Why?
I think because he sees the light or he sees something above, and it's his way of reaching, but when his reach, he does this. So It's really funny at first, but not when it's in public. So it. I'll explain later. All right. No, he's not Hitler. He's too cute and adorable. Okay. Let's talk about powers and exponents. Now, like I said, I just wanted to give you a quick little miniature background knowledge, oh, that's right, I wanted to give you the shortcut. Woo! Scratch that off.
Oh, good. I just
The bell's not that loud, but it's trying. No, I'm not going to smash it. So the shortcut, if you notice, when we had one number repeat, what was the fraction put over? 1/9. Shh. Quiet. When we had one number that was repeating, like the 0.7, we put the fraction over 9. When we had two numbers repeating, we put the fraction over 99. When we have four numbers repeating, it was put over 9,999. So if you see the shortcut, however many numbers are repeating, you put that many nines under it and then simplify. That's it.
Wait, what? Is this a
Now, that only works, quiet, that only works if you have the situation where it's just repeated numbers and no non-repeats in front. So if you had something like, oh, 2, and then 4, 4, 4, 4, 4, 4, 4, wouldn't work that way.
But if you just have
So if you just have 2, 2, 2, 2, 2, 2, 2, then it would just be 2 over 9. If you had, 0.171717, it's 17 over 99. Okay? That's a shortcut. I don't know why I scratched that off, because I could just verbally verbalize the shortcut.
Like, you'd be like,
We're writing it again.
so like for the first one, 0.8, we just write down 18 over 99.
Yeah.
Yo, that's
Now,
easy.
that itself is not going to be on the actual unit test. We're not putting that stuff. It'll be on a quiz, but it's not going to be on the unit test. All right, so powers and exponents. So the basic idea for a power and an exponent, you've got a value like 5 to the third power. That 5 is identified as the base. That's our base. And that 3 is our exponent. And of course, that exponent is going to tell us how often we're going to repeat multiplication on that base. Okay, so it tells us how many times the base is used as a factor in multiplication. Oi. Thank you. You're annoying. Okay, so if we have 5 to the third power, or 5 cubed, okay, when you have a second power or a third power, you've got alternate names that can be utilized to identify that expression or that exponent value. So when we have 5 to the third power, if we were to write it out in expanded form, that would just be 5 times 5 times 5. So 5 times 5 times 5. Now, when we state it, the one thing that I cannot stand is when you guys go, oh, it's 5 and the little 2, or it's 5 and the little 5. You need to know how to properly identify these. It's a power of, 5 to the power of, or raised to the power of, or again, it has some alternate names. Some of them do, some of them do not. So if you've got 5 to the first power, it's written as 5 to the first power. That's how you would state it. When you've got 5 and the exponent is a 2, we call it either 5 squared, which is the more common one, and I'm going to put a star next to this. 5 squared, or you can state 5 to the second power. When you have an exponent of 3, we would call it cubed, so I'd say 5 cubed, or you could say 5 to the third power. It is. It's all about dimensional, Arham. It's all about dimensional shape. So when we talk about like area is the second power because it's on a two-dimensional shape. But when we talk about volume, volume is always to a third power because it's a three-dimensional shape. So it's cubes are three-dimensional, squares is a two-dimensional. So it's just, but those are the only two. Those are the only two. Guys. Those are the only two exponents that have alternate names, squared and cubed. After that, then you just go right on to saying it's always this to the power of, you know, that, or to the fourth power, the fifth power, the sixth power, and things of that sort. Grant.
Isn't there another dimension? Time?
Huh?
Time dimension?
Honey, we're not talking about that. We're talking about shapes.
The time dimension?
Okay.
5, 4, 6, 5.
Now, there are, quiet guys, there are quite a few things that I'm sure you guys know already about exponents, but there are also some things that you don't quite know when it comes to exponents. And I'm pretty sure that one of the couple questions that I might pose to you guys, you're going to get them messed up. So, for the following stuff, I want you to write the following in what's called exponential form. Okay, 4 times 4 times 4 times 4 times 4. Who can tell me what that's going to be in exponential form? Annie? 4 to the fifth power. Okay, you've got 1, 2, 3, 4, 5 of them that are going to be repeating, so it's 4 to the fifth power. If I've got 3 times 3 times 6 times 6 times 6 times 6. I want it written in exponential form. What is that going to be looking like? Joshua?
3 squared times 6 to the fourth power.
Very good. 3 squared times 6 to the fourth power. You've got 2 3s. You've got 4 6s. So 3 squared times 6 to the fourth. Who wants to come up to the board? Or, yeah, who wants to come up to the board and write this one? Go ahead, Colin.
Oh no, I wrote 3. Boy, look how pretty they are.
Can you write it bigger, please? Okay, so he's wrong. Now, here's why it's wrong. So what he put down would be marked wrong because it needed to be in parentheses. Now, let me explain to you why. And this is one of the things that's going to make people get things messed up. It might not matter so much in a problem like this one, but if I were to tell you -2 times -2 times -2 times -2, when you write this out, it has to be in parentheses, because if you don't include the parentheses, right now, if I were to multiply this, my answer would be a positive. If I didn't include the parentheses, then the answer would be a negative. The parentheses indicates to you that not only is the number repeating, but so is the negative. When you don't include the parentheses, you're indicating that the power only exists to the number and not the negative sign. So when I write something like -4 to the second power, this is not the same thing as -4 to the second power without parentheses. Here, this would be -4 times -4, which would give you 16. For here, this would be -4 times 4, which would be -16. Not the same thing. Do you guys understand? It is vital that when you have a negative, you put it in parentheses if it is part of the repetition. Okay? So for here, something like this would be -2 to the 4th power has to have the parentheses around it. Okay? Same thing for a problem like this. Two-thirds times two-thirds times two-thirds. You have to put the whole thing in parentheses. 2/3 in parentheses to the 3rd power. If you did not, so make a little side note, without the parentheses, if you had 2/3 to the 3rd power, this would indicate that you're only doing 2 times 2 times 2, and it would be over 3. Because the power without the parentheses would only be to the numerator and not to the whole thing. When you include the parentheses around it, it means that this entire fraction is being raised to that exponent. Now, if you wanted to, you could also write it without parentheses as saying 2 to the 3rd power over 3 to the 3rd power. Either one of those would be acceptable. Any questions?
Is the parentheses always on the outside? No, the exponent always on the outside of the parentheses.
Yes, when you're writing it in exponential form, you would put the exponent outside the parentheses. Now, in a few days, you're going to be learning about powers of powers, which means you will have exponents inside and outside, and we'll talk about how you use distributive property from the exponent.
So it could be like 6 squared.
So you could have 6 to the 2nd power to the 5th power.
Wow.
So that would be 6 to the 10th power.
Oh, you can just add them.
Multiply them. You'd multiply the exponents.
Oh, and
When it's a power raised to a power. Yeah. When the only time you add exponents is when you've got same base to a power multiplied by same base of a power. So like 3 to the 4th times 3 to the 2nd, that would be 3 to the 6th. But we're going to get into that tomorrow. This right now, we're just doing a basic review of our powers. Okay? All right. Yeah. It would be wrong. So if you put parentheses, but you put 2 to, so if you did, wrote this, but put parentheses outside of the exponent, then it would still indicate that you're doing 2 to the 3rd power over 3. That's why the exponent needs to be on the outside of parentheses, because it's saying that, hey, everything that's in here, I'm going to repeat it, repeat it, repeat it. Okay? All right. I want you guys to go ahead and simplify the following as much as you can. No, I didn't. I'm testing that you understand the idea of parentheses versus not parentheses.
A squared plus B squared equals C squared.
Shh. Mm-hmm. Is this going to be what? This is our new unit, yes. Exponents in scientific notation. Yes, sir.
We only have to super add.
Only, well, you're working it all out. So you're going to get your final answer. Shh, absolutely. If you need it. I mean, there shouldn't be a need for it, but
What do we do with number 5? We just put AA,
well, but you've got the values for A and B.
Oh, I know that.
Yeah, I know you knew that. All right, who can raise their hand, tell me what they got for number 1? Elijah?
Negative 5 times negative 5 times negative 5 times negative 5.
Which equals what?
Parentheses negative 5 parentheses 4.
You had to actually simplify the whole thing, work it out. Grant?
65.
Not 65. Lena? Quiet. This would be equal to 625 because you're doing negative 5 times negative 5 times negative 5 times negative 5.
Well, I added
You
those.
said 65. Quiet. Colin, take a seat. I don't know why you're standing. I don't care that you don't want to sit. Number 2. Jordan.
36 over 49.
Yes. 36 over 49. Number 3. Josh.
Oh, that's what you meant by simplify.
Huh?
I'm done. That's my bad.
Just leave it in improper form. I want you guys to start getting used to the idea of leaving things in improper because next semester you're going to need improper fractions. 36 sevenths. Good. I should have told you that from the beginning. Number 4. Colin. Negative 625. And then number 5. Annie. 634. Because you're going to have negative 3 to the second power plus 5 to the fourth power. Negative 3 to the second power is 9. 5 to the fourth power is 625. And when you add 9 and 625, you're going to get 634. I didn't have to put parentheses over the A. Hold on, listen. Because if you were to write it out, it would be A times A. Or negative 3 times negative 3. So to indicate that it's negative 3 times negative 3, they would have to be parentheses. It's A to the second power, meaning whatever value A is, that's naturally in parentheses. Okay? All right. You guys have an assignment to do, and you have until 10:50 to get it done.